Hey everybody, this is Mrs. Hilt, and in this lecture we're going to go over the periodic table essentials for bonding. Please follow along with the lecture slides and have a periodic table available. All right, so here is the full-length periodic table. Recall that we have talked about the S block, the S block also includes helium, D block, and F block. Now, there are other ways that the periodic table is grouped, and one of those ways, and one thing that we're going to look at in this lecture, is the different families. So the different families, like the alkali metals here in red, alkaline earth metals, lanthanide, actinide series, transition metals, halogens, and noble gases. These all have similar properties with one another, and we call them chemical families. Just like how you and your families have similar characteristics, maybe you have the same nose or the same smile, same eyes, hair color, stuff like that. Elements that are in the same family on the periodic table also have similar characteristics or similar properties, and that is all based on the number of electrons they have in their very outside shell. All right, so first, the organization of the modern periodic table. Elements are arranged by increasing atomic mass, or atomic number, not mass. And that is because elements increase based on their number of protons as you go down the periodic table. This does impact the mass because when you add a proton, you increase the mass by 1 AMU, but because of the differing numbers of neutrons that isotopes of atoms can have, we don't rely on the mass for the organization, we rely on the atomic number. There are 7 periods, which are the rows that run horizontally on the periodic table. And there are groups, which are the columns, and there are 18 total groups on the periodic table. These are the groupings of elements, have similar properties and chemical behavior, and that's why I was calling them chemical families on the last slide. Periods running horizontally, and elements and periods do not have similar properties. They do have similar energy levels, but because of the different numbers of electrons in their outside energy level or their very highest energy level, that results in different properties. Elements in the same group do have the same number of electrons in their very outermost energy level or their very outermost shell, therefore resulting in similar properties. All right, some more breakdown. The main group of elements, these are the S and the P block. The group numbers are 1 and 2, and then 13 through 18, which are also referred to as 1A through 8A. And I'll get to that, or get to the explanation as to why very shortly. The D block elements, these are the transition metals, and they all have similar properties with one another. And then the F block elements, these are generally radioactive elements, and these ones, even though they're periods, they will also have similar properties with one another. And that is really the only grouping on the periodic table where the periods have similar properties. Everything else, the groups will have similar properties due to their valence electrons. So here's an example, group going up and down. This is group 2, starting at 4 and going down to 88. Period 4 goes from 19 all the way through 36. So period 4, these elements do not have similar properties. They do have the similar energy level. But group 2, these elements will have similar properties with one another. All right, and then that leads us as to why they have the similar properties, and it all stems from the electrons. So elements in the same group have the same number of valence electrons. Now recall that the valence electrons are the electrons in the very outermost energy level or the very outermost shell of the atom. Right? And these are the electrons, the valence electrons, are the ones that are involved with bonding. So if elements have the same number of valence electrons, they are going to be bonding in the same fashion. And that is how they have similar properties when they're in the same group. Okay. All right, now the number of valence electrons that different groups have. If the element is in the S or the P block, the number of valence electrons will be equal to the group, other than helium, because helium is a special case. So all group 1 elements will have 1 valence electron. All group 2 will have 2 valence electrons. Then when we jump across through 13 to 18 or 3A to 8A, the reason why we say 3A through 8A is because that first letter, or that first number, tells us the number of valence electrons. The elements that are in the transition metal block or the D block, they have varying number of valence electrons, so we cannot identify them as easily as we can groups 1, 2, and then 3A through 8A. Same with the F block. Here's what the valence electrons look like. So group 1, 1 dot or 1 valence electron. Group 2, 2, 3A or 13, 3, and so on, all the way until we hit the noble gases, which all have a very complete outside shell, meaning that they don't want to bond with anything. They are satisfied elements because that shell is full. And that's why it's okay that helium only has 2 valence electrons, because since it is in period 1, horizontally, period, it only has 1 shell, and shell 1 is full with 2 electrons. Okay? So all elements want to be like the noble gases, and that leads us into how the bonding occurs. All right, so when atoms bond, charges are formed, or ions are formed. The different ion charges are based on the number of valence electrons that an atom has. So because group 1 elements, lithium, they have 1 valence electron. So that means it's way easier for lithium to give away 1 electron than try to achieve or get 7 more. That would be quite a lot of electrons to grab from other elements. So it's easier to give 1 away, and when you lose an electron, lithium ends up with a positive 1 charge, and that is true for all elements in group 1. For group 17, for example, fluorine has 7 valence electrons, so it is much easier for fluorine to try and take away an electron from another atom instead of giving away 7 electrons. And when it gets its 8th electron to have a complete outside shell, because there's 1 more electron, then it will have a negative 1 charge. Same pattern follows for all of the other groups, for 1, 2, and then 3A through 8A or 7A. So in general, metals on the periodic table, they lose electrons and they form cations. Okay. And metals are all of the blue elements. And because the metals make up all of group 1, other than hydrogen, that one's an odd case, all of group 2, and basically all of group 3, when they need to form when they need to form their octet or try to achieve their octet, group 1 needs to give away 1 electron, group 2 give away 2, group 3A give away 3, and since they are giving away electrons, they are becoming positive. Then the exact opposite happens for the nonmetals. So in general, the nonmetals are on this side of the periodic table, and fluorine and chlorine and all of the other halogens in this group, they only need 1 electron to have that complete outside shell. So they need to achieve an electron, which causes a negative 1 charge. Group 16, same thing, but 2 electrons, 15, 3 electrons. So that's why in general, nonmetals form anions and metals form cations, just based on their general location. Metals tend to gain electrons, forming anions. Okay. And recall I've been talking about this octet rule. When an octet rule is achieved, this is the electron configuration that will result, and this is the configuration of all of the noble gases. All right, now jumping into the families and periods, a little quick review on this. So families are the columns or groups on the periodic table, and elements in a family with one another have similar properties, but they are not identical, because as you go down the groups on the periodic table, you are also increasing the energy levels. Therefore, they're not the same, but they will bond and react very similarly due to the same number of valence electrons. Then for the periods, these are the horizontal rows, and elements in a period are not alike in their properties. And it actually changes very drastically as you go left to right across the periodic table, because every time that you move across the periodic table, you are adding an electron. So that changes how many electrons that those atoms have to give away or take from another atom or share with another atom to form a complete outside shell. So now, when these charged atoms or ions are formed, we have ionic bonds that result. So if we have a metal, and we can keep using that lithium and fluorine example. So lithium has 1 valence electron, where fluorine has 7. And for each of them to become happy with a complete outside shell, lithium can transfer one of its electrons. Lithium results in a positive charge, fluorine a negative charge, and it results in an ionic bond. So ionic bond formed between ions, and when that happens, electrons are transferred. The other type of bonds are molecular or covalent bonds. This happens between two nonmetals, and they share their electrons with the same idea to have a complete outside shell of electrons, but instead of transferring, they share them, and both will feel like they have a complete outside shell. So transferring for ionic, and covalent is sharing. One way I like to remember the covalent one is that sharing is caring, caring is covalent. I know we've all heard the sharing is caring phrase before, and covalent starts with a C, so that's how I came up with that one. All right, another example with ionic bonds, transfer of electrons between atoms, and this happens when we have a positive cation, which is metal, and a negative anion, or a nonmetal, and they form an ionic bond between those two ions. And diving more into the covalent bond, there are a few different terms. A molecular bond, which just means that the bond contains 2 or more nonmetals that form a covalent bond. And then specifically, a covalent bond is when the valence electrons are shared between the 2 nonmetals to achieve stability, or an octet. And when 2 or more atoms share electrons, they form a molecule. All right, to sum this all up, these are the type of elements on the periodic table. In general, the metals are on the left, nonmetals are on the right, and then that staircase that separates the nonmetals and the metals, and these are the metalloids, or the semimetals. We have different groups, which are the different families on the periodic table. They have similar characteristics because of their number of valence electrons. Group 1 or 1A is the alkali metals, and they form positively 1 charged cations because they want to give away 1 valence electron. Group 2 or 2A, alkaline earth metals, form positive 2 cations. Group 17 or 7A, the halogens, negative 1 anions, noble gases. They have a complete outside shell, what every atom is trying to achieve, so they do not have a charge. And then the middle group are the transition metals. Lastly, ionic bonds are formed between metals and nonmetals, and electrons are transferred. And covalent bonds are formed between nonmetals, and electrons are shared. All right, thanks for watching.